Okay, so imagine this for a moment. A machine built with 1970s technology, launched when disco was on the radio, when personal computers didn't exist, when the internet was science fiction. Now imagine that machine is still alive, traveling at over 60,000 kilometers per hour, so far away that its signal takes more than 20 hours to reach Earth, so far that no human will ever physically reach it. Now imagine that in 2022, it started sending signals that make no sense, signals that shouldn't exist, and the engineers monitoring it don't fully understand why. Its name is Voyager 1, a mission that was supposed to end in 1982. On August 20, 1977, Voyager 1 launched with a simple 5-year mission: study Jupiter, study Saturn, send back data, shut down. That was the plan. But space had other ideas. 47 years later, it is still operating, still transmitting, and it is now the most distant human-made object in history. It travels at about 17 kilometers per second. That's roughly 60,000 kilometers per hour. For comparison, the fastest production car in the world barely reaches 490 kilometers per hour. Voyager moves over 120 times faster. And yet, even at that speed, it will take 300 years to reach the inner boundary of the hypothetical Oort cloud. After that, around 30,000 more years before it passes anywhere near another star. Space is not big, it's incomprehensibly big. How far is far? Right now, Voyager 1 is more than 150 astronomical units from Earth, over 23 billion kilometers away. Sunlight takes 8 minutes to reach us. Voyager's signal takes more than 20 hours. And by the time it arrives, it is unimaginably faint. So faint that NASA needs 70-meter-wide radio antennas to detect it. The machine speaking to us from interstellar space is smaller than a compact car. It weighs less than a ton. Its onboard computer has less processing power than your phone. And yet, it is still talking, still reporting temperature, radiation, particle density. After nearly half a century, no maintenance, no repairs, no upgrades, just endurance. And then something changed. In May 2022, engineers at NASA's Jet Propulsion Laboratory noticed something strange. Voyager 1 was still sending data, but part of that data made no sense. The system that controls the spacecraft's orientation, the one responsible for keeping its antenna pointed at Earth, began reporting impossible values. It claimed the antenna was misaligned, pointing in the wrong direction. And yet, the signal kept arriving perfectly, strong, stable, accurate. It was as if the spacecraft were saying, "I'm lost," while staring directly at us. No safe mode, no failure, no clear cause. NASA checked everything. The spacecraft had not entered safe mode. No backup systems had activated. No obvious hardware failure appeared. All other instruments continued functioning normally. Only the attitude control telemetry, the orientation data, was corrupted. Susan Dodd, project manager, stated something quietly unsettling. No spacecraft has ever operated this far from Earth. That sentence matters. We are receiving data from a place we do not fully understand, from an environment no human technology has ever endured for this long. The official explanation? Radiation. Interstellar space is saturated with high-energy cosmic rays, particles born in supernova explosions, particles accelerated near black holes, particles powerful enough to pass through metal. After nearly 45 years of bombardment, electronic degradation is expected. That's the explanation. Logical, reasonable. But here's what unsettles some engineers. If radiation caused the issue, why did it affect only that system? Why are other subsystems functioning normally? Why does the spacecraft still execute commands perfectly? When NASA tells it to activate an instrument, it does. When NASA tells it to adjust trajectory, it complies. It only lies when asked where it's pointing. It's as if one part of the machine is fully aware and another part is confused, divided against itself. The communication problem. There is something else people rarely consider. You cannot fix Voyager. If NASA sends a command, it takes 20 hours to arrive. If Voyager responds, it takes another 20 hours. Every question requires 40 hours, almost 2 full days per exchange. Imagine debugging a system you cannot touch, cannot see, cannot repair. And while you wait, it keeps moving, 17 kilometers farther every second, more than 500 million kilometers every year, drifting into deeper darkness. It's not just far, it's somewhere else. Voyager 1 has crossed the heliopause. It is no longer in the solar wind, no longer protected by the sun's magnetic field. It is in interstellar space, the real universe, unshielded. The particles striking it now have traveled for millions of years. Some were born in dying stars before humanity existed. Every second, those particles hit Voyager, altering circuits, flipping bits, slowly reshaping the machine at the atomic level. Perhaps the strange signals are not a malfunction. Perhaps they are a consequence of existing in a region we have never tested technology in before, a region we barely understand. The clock is running out. Voyager is powered by radioactive thermoelectric generators. Plutonium decays. Energy decreases. Every year, NASA must shut down another instrument to conserve power. By 2025, only a few sensors will remain active. By around 2030, Voyager 1 will likely fall silent, not because it crashed, not because it failed catastrophically, but because it simply ran out of energy. And then it will continue, in silence, for millions of years. The golden record. Voyager is not empty. Attached to its body is the Voyager Golden Record, a gold-plated copper disc, a message for whoever or whatever might find it. It contains 115 images of Earth, human anatomy diagrams, DNA structure, a map of our solar system, coordinates of our position in the galaxy, greetings in 55 languages, 90 minutes of music, from Bach to Chuck Berry. There are instructions engraved on how to play it, a simple diagram explaining how to decode it, a message without words. This is who we are. This is where we lived. We existed. The uncomfortable truth, by the time anyone finds Voyager, humanity may be gone. Voyager 2, the silent twin. Voyager 1 is not alone. Its twin, Voyager 2, launched weeks earlier. It visited Jupiter, Saturn, Uranus, Neptune, the only spacecraft ever to do so. To accomplish that, it changed trajectory, passing over Neptune's pole and exiting the solar system in a different direction, so far south that only one Deep Space Network antenna can communicate with it, in Canberra, Australia. In 2020, that antenna shut down for upgrades. For 11 months, Voyager 2 transmitted into the void, no one listening. When the antenna came back online and sent a test command, Voyager responded. It had been waiting. The bigger question: Voyager 1's strange signals remain partially unexplained. Engineers have isolated the faulty telemetry source to a specific subsystem memory location. They suspect corrupted data routing, but the underlying trigger? Still uncertain. And here's the deeper thought. Voyager is the first human object to enter interstellar space, the first witness, the first ambassador. We sent it without fully knowing what lies beyond. Now it is behaving in ways we don't entirely predict. Not dramatically, not catastrophically, just strangely. Maybe that's normal. Maybe that's what happens when you push technology beyond the environment it was designed for. Or maybe it's something simpler, a reminder. A reminder that we are sending pieces of ourselves into places we barely understand. And one day, in 300 years, Voyager will reach the inner Oort cloud. In about 40,000 years, it will pass near a red dwarf star called Gliese 445. After that, it will orbit the galaxy for millions of years, long after Earth has changed, long after our civilizations have risen and fallen, long after our sun begins its transformation into a white dwarf. Voyager may outlive humanity, a small machine carrying images of people who no longer exist, music from cultures long forgotten, a message carved in gold saying, "We were here."
There is something profoundly human about that. Voyager isn't just a spacecraft. It's a promise. A promise that even if we disappear, something of us will keep moving, keep traveling, keep asking questions. And somewhere, 23 billion kilometers away, a machine built before most of us were born is still trying to speak, sending signals through darkness, signals we are still trying to understand. Maybe one day, when we send the next probe beyond the solar system, we'll finally understand what Voyager was experiencing. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe, and keep listening to the silence.